Hi lads, in this video I'm going to go through how to do the 2016 higher level question 4. It tells the elevation plan of a safety guard for a garden strimmer is shown. The safety guard consists of a truncated semicolon A and a cylinder B, which is also truncated as shown, and a 3D graphic of the guard is also shown. Part A, draw the given plan and elevation, so basically these two views here. Part B, project an end view in the direction of arrow P, so what do we basically see when we look in at that direction there. Part C, draw the development of the conical surface A, so this section here was it looked like it was folded out flat. And then part D, draw the development of the cylindrical surface B, so basically the cylindrical part here when it's rolled out flat as well. So to start the question, I'm going to draw the plan first. Just take the line across there and the line down there, and that's going to give me my central axis for my circle. So it's a diameter of 120 for the outer one, so I'm going to take 60 on my compass there for that. And it's only in heavy on the right hand side. And the inner one is diameter 28, so that's going to be a radius of 14. And that circle is seen heavy all the way around for the cylinder part. So let it focus there for a sec. And just drawing heavy between them 2 points there. So next after that, it's my actual plan, so I'll just put a little gap in between there, and I'll take all of these widths up here. So the heights I'm given in plan are first of all 16, there's then 40 and then 20. And that 20 only goes up to the centre of where the sloped cut is taken on the cylinder. So that slope is at 30 degrees, so from that 20 I'm just going to take that 30-degree line there. And the 2 vertical lines will drop down to both here and here, and that can be taken across then. Where I go up 20, I can draw in heavy here, and it only goes across to my central axis. And then from this point here, I'm going to connect that to the edge there, and that gives me A there and B there as a result. So that's my elevation and plan, so that's part A of the question complete. So part B is drawing the end view, looking in on that side there. So I'll just draw in this side here, just even though it's not needed, just drawing what it would look like if I had there, just to show what it exactly is in the question as well. So what we need to do is take across all of these widths here, and then take them up at 45 degrees to draw our end view. And just extend that Y line out, and then take them up. take my heights across as well. So at the moment I'm just going to focus on the bottom half for now. So for the bottom half, when we look in this way we can see the whole width of the bottom there. So it's not going to be cut in half as well, we can see the whole thing. And then we have our two sloped lines for a conical surface coming up here and here, and that's taken across there as well. For the cylinder, it's not just going to be two lines going straight up and then this point coming across. Because there's a cut, there's going to be a curved surface there, like an elliptical surface. So what we need to do is we need to draw on that elliptical surface here. So when we look in from this side here, we can't see the lower half of the cut at all. The start of the pair is below the line here, so it's going to be dashed, and the above part we can see is going to be heavy. So what we need to do first is divide up. Just like when we're drawing any curved surface at all, we divide up our circle into a number of equal parts to give us points. Because as we know, there's no edges on a circle that we can actually mark as points and take them up and across. And just label them out. I've them all labelled out, I can take them all up then as a result. See where they hit the slope surface. So with them all labelled, I can then start taking them round and across. So for example, I'll start off with just A first. So A comes out, over and up, and then A is here. So that's the first one. Then go around to B. So take B across, up to 45. Straight up, and B, when taken across, is located there, and it's the exact same for the rest of them. And D is actually the very bottom one, and D I already have drawn there for the centre. And then I can take across E and F together there. So E is on the same line as C, so I just take that across a bit further there to give me E there. And then F is also on the same line as B, so I can take F there. And then G across to here. You can see G there on the outside, I already have it marked off. And then I can draw that in the lower half, and because it's been blocked by this longer surface here, so you can see all the surface here below, it's not going to be able to be seen. I can draw that in, and it appears dashed there, and then my sides are going to be heavy up to there, and then the top half I'll be able to see then as a result. The top half I'm going to start going from G around to H, so H and F are on the same line, so we take that up there, find H here, and there's H. I is going to be the same line as E, just extend that out. There, and then J, very top one, is on the same as D, so follow that up there, take it up, hit it across, so you have J there as a result, and then after that you have K and L. Then K is going to be on the same line as C, and then finally the last one, say B up there, because B and L are on the same line, and that's going to end there. And then that can be drawn in heavy as a result. And there's our curved surface now drawn in, and that completes our end view of the question. So that's part B done. So part C then tells us draw the development of the conical surface A. So basically this surface here. So because it's conical, meaning it's a cone, and I just have the top chopped off there. To get the extreme generator, which is going to be our true length we've seen in previous questions before, we can just extend that out there where it hits our axis. That's our true length there of on the sides of our cone around the generators. So what I can do is I can just pick a point anywhere, like here for example. Take a line out at an angle. It's going to be one of our sides. Take this distance on my compass. From there, swing that around, and with this question you have to remember it's only half of that base there. So I draw a half of it. So what I can do is I can extend out my 30/60s for this side here. I'll label these, so 0, 1, 2, 3, 4, 5, 6, and then I can step them out. So I take these distances on my compass, they're all the exact same, so mark that there as 0, so 0 goes to 1, then 2, 3, 4, 5, and finally 6. So it doesn't close back on itself again, it only starts between here and then ends there. So I can connect all those together then. And they're going to be where my fold lines are going to go. And then we can see that this part here is going to be cut off from the cone. So what I'm going to do is, because that's a true length from there to there, this is also going to be a true length. So it'll give me the cut surface then between two extreme ones at focus. I can now draw in the actual shape I'm going to have. And finally the outer one. Let's label these again. All the way around to 6. And then draw the outer arc in heavy as well. That completes part C. So part A here, part B here, part C here, and then part D is to draw what this conical surface looks like, or sorry, cylindrical surface looks like when it's rolled out flat. So because I have all my heights here, what I can do is just simply extend out my heights here and then use them. So what I can do is I can start just here and say that's my end. So we can see with the question we have all 12 going all the way around. So I can take this distance on my compass, already divide it up into 30/60, and I have it labelled as well. So I'm going to start off with A as well and work my way all the way around back down to A again. So A to B, B to C, C to D, E to E, E to F, to G, H, I, J, K, L, and then finally back to A because it closed up. So there's all my divisions stepped out, and I'll just label them as well. What I'll do for now is I'll just take all those straight up, and then where my heights are, I can take them across, and I'll be able to draw my development then. So all this is drawn in lightly once again. So starting off with A. A is the very centre one here. So I'm going to mark off the height A and A there. Then B is down here. C is this height here. D is the lowest one, and then it goes up to E there. Oh, missed it there. E should be there. So let's mark there F so I know where I'm going this time. F is going there. G is marked off as here. H is going to go to there. F, I, J, K, and L there. I is there. J is the very top one. K then drops down one there. L drops down a further one there. And then finally back to E as a result. And I can draw in heavy what that development would look like then. And then draw in curve. Now your curve could be different depending on where you actually start the question. So if I was, for example, start at G instead, your curve would look slightly different compared to my one. But once this is all folded, joined up together, it'll still give you the same shape as a result. If I have to cut that out and roll it up. And just draw your fold lines. And that gives me part D, and that finishes the question off. Just to show you what I mean by that. So if I was just to go to the solution there, you can see, for example, that year, when they did the actual solution, you can see how they start off with 2 even points at each end. So they would start off at the lowest point there and work their way to the top and back down. That's perfectly accepted as well, and so was the way I've done it. I've decided to start at A, where the first letter was, and then work my way around all the way back to A again. Still get the exact same answer as a result. So hopefully that video helps anybody who has been stuck on that question.